Welcome to a quick start video for the P1150, a wide dynamic range current measurement power supply. Once you run the client app that you've downloaded from the website, it'll find your device plugged in on a COM port. You can also check for updates, and I recommend you do this often because there's updates coming pretty rapidly. Once I select the P1150 to operate, the P1150 will calibrate. This takes about 17 seconds. While we're waiting for calibration, I'll just let you know that the target that I have today is a Raspberry Pi, and I've connected up the probes to the 5-volt input on the header, and we're just going to power that up and look at its profile. Along the left-hand side control panel, I have an ammeter at the top, which will show the average current every 1 second. And right now we have no current, even though we're not connected to the load. This ammeter is actually active in the background. Then I have the output, and we're going to get this to 5 volts. I could also move the slider. Sometimes it's easier to use the controls. We have a connect button. We have the auxiliary input enables, so if we enable these inputs, we can plot them at the same time. We have some P1150 hardware information that's attached, and there's a screenshot utility here. When I start with a new project, I like to use the logger tab, which is a long-running, continuously running logger type plot of the current. And let's do that now. When I hit run, I'm going to see the noise floor of the P1150 because I have not connected to it yet. This is 1 microamp or 0.001 milliamps, and that's the noise floor of the P1150. Once I hit connect, we're going to see the current jump right up, and we're going to see that the Raspberry Pi is doing some work. This Raspberry Pi is connected up in headless mode and is actually running DiaPi OS, not Raspberry Pi. This table here is plotting the average statistics for the entire plotted range. I'm going to stop it now. If I use the middle mouse button, I can zoom in to see what the current is doing, and I have markers that I can place and move around, and I also have cursors which I can adjust. When I put the cursors on, this second table shows the information regarding those cursors. The oscilloscope plot is like an oscilloscope, so it's currently set to 200 milliseconds wide, and I can adjust that. And if I fit the current, I can see much more detailed information. I can also set a trigger on the current, which is out of view, so I have to slide the current line here, then get back to fitting the current. And now I'm getting a trigger when the current reaches that. If I do a single, maybe I can catch that step. Yeah, interesting. I don't know what it's doing, but I can capture this, find out how wide it is. It's about 84 milliseconds wide, and there's 35 millicoulombs in that. The milliamp hour plot is for capturing very long running traces. I fit the current. And the interesting thing about the milliamp hour plot is it downsamples the data so that you can plot a lot more data. But during the downsampling, it keeps track of the min and max current. So if you do have any kind of wake up event, the P1150 will plot it, but it also shows you the average current. Sometimes with switch mode power supplies, because the current is PWM, this is an interesting way of looking at the current. If I double click anywhere in the plot, the zoom goes back out. And on the milliamp hour plot, I can actually set the bandwidth or the window. And that's it for a very quick demo. I guess one more thing is in preferences. You have the ability to set the button voltages to something that suits your application, and you can set the path for exporting data screenshots, and you have the option of checking for an update every time you power up. Thank you.